In this module, you will learn about non-conservative forces. Based on the energy transfer during the work done, force can be classified as conservative force or non-conservative force. You already know that if the work done by or against a force is independent of the path followed, then the force is called conservative force. By contrast, if the work done by or against a force depends on the path followed, then the force is called non-conservative force. To understand this further, let us study different cases where a wooden block moves from point A to point B along different paths on a rough surface. In the first case, the block moves along a straight path from point A to point B as shown here. Let the work done in moving the block against frictional force be W1. In the second case, the block moves along a curved path from point A to point B as shown here. Let the work done in moving the block along the curved path against frictional force be W2. In the third case, the block moves along an arbitrary path from point A to point B. Let the work done in moving the block along the arbitrary path against frictional force be W3. In all the three cases, the block moves across different distances. Now, frictional force depends on the distance covered by the block. So, the frictional force acting on the block as it moves across three different distances is different. Hence, the work done in each of the three cases is also different. Therefore, we can say that W1 is not equal to W2, which is not equal to W3. Let us look at the fourth case, where the block moves along a closed path on the rough surface. The block moves from point A to point B along the path as shown here. Let the work done in moving the block along the path against the friction be W4. The block moves back from point B to point A along the path shown. Let the work done in moving the block along the path be W5. Here also, work is done against friction. The frictional force on the block is different for each different path. Hence, the work done to overcome the friction along each different path is also different. So, W4 is not equal to W5. As a result, the net work done along the closed path is not zero. It is mathematically expressed as closed integral f dot ds not equal to 0. This equation is applicable to all non-conservative forces. Since frictional force depends on the path followed, it is also an example of non-conservative force. Some other examples of non-conservative forces are viscous force, air resistance force, and tension force. Let us now understand what happens to the energy of a block when a non-conservative force acts on it. Consider a block moving from point A to point B on a horizontal rough surface. While the block moves on the surface, frictional force opposes the motion. Let the work done against the frictional force be W. When the block moves back from B to A, again, frictional force opposes its motion. The block covers the same distance along the return path. So, work done against friction when the block moves back from B to A is the same as W. Consequently, the net work done against friction in a round trip is equal to 2W. Since the kinetic energy of the moving block is lost for doing this work, this net work done is numerically equal to the loss of kinetic energy during the round trip. Consider another scenario where a block slides down from a height on an inclined plane. When it slides down, it has both potential energy and kinetic energy. The potential energy is due to its height and the kinetic energy is due to its velocity. Thus, the total energy of the body is equal to its kinetic energy plus potential energy. Let the total initial energy of the block be EI. When the block slides down, a non-conservative force of friction acts on the block. Here, work is done against the non-conservative force of friction. Since the work done against the non-conservative force, the moving body loses some energy. Let the total final energy of block be EF. The lost or dissipated energy is equal to the total initial energy minus the total final energy. This dissipated energy is equal to the work done against the non-conservative force. Let work done against the non-conservative force be W. So, W is equal to EI minus EF. When work is done by a non-conservative force, the dissipated energy is released in the form of heat, sound, light, and so on. Thus, by taking all these forms of energies into consideration, the law of conservation of energy is applicable to non-conservative forces. You have now reached the end of this module. In this module, you learned that based on the energy transfer during the work done, force can be classified as conservative force or non-conservative force. If the work done by or against a force depends on the path followed, then the force is called non-conservative force. For non-conservative forces, the net work done along a closed path is not zero. Frictional force, viscous force, and tension force are some examples of non-conservative forces. The work done against a non-conservative force W is equal to initial energy minus final energy of the body. When work is done by a non-conservative force, the dissipated energy appears in some other forms like sound, heat, and light.